Hello, thank you for joining me. Today I want us to look at moment of force about a point. Now, just before we start, let us take a little look about what this moment is all about. In our everyday life, example, if you want to turn on or turn off a tap, now we turn it either clockwise or we turn it anti-clockwise. Now that by turning it you exert force. That force you exert there is called turning force, and it produces a turning effect. So that turning effect that time is what we refer to as a moment of force. So in other words, by definition, we can say that moment of force is turning effect of force about a point of support, a point of pivot, or a point of fulcrum by a force. Now, that turning effect, most times we can now say that yes, moment of force can be represented mathematically as product of force and the perpendicular distance of the point along the line of action of force. Now, assuming we have a bar of this nature. Now, if that bar is pivoted at a point, now maybe if a mass is hanging at one side, then another mass is hanging on this side. Now we can now say that yes, this is a force or a mass. This mass is that force here, downward force. Now we can say here is F1. Now this one here is F2. We can talk of perpendicular distance. Of course, this distance is perpendicular to this force, 90 degrees. Now this distance from here to the point of a pivot, from the point, the line of action here to the point of pivot, that distance we can say it is x1. Now from here to this one also, we can call it x2. Now the product of force and the perpendicular distance is what we refer to as moment of force. Now we can now say moment of force, is a product of this force F1 and the perpendicular distance x1. Now the SI unit of moment of force is, we can derive the SI unit from this. This is F. F is measured in Newton. While this one x is distance. You can use x, you can use d, you can use r to denote your distance. So I'm using x to denote my distance. So x is in meter. Therefore, the SI unit of moment of force is Newton meter. Now let us look at principles of moment. Now the principle of moment states that yes, if this body is in equilibrium, then force in one direction is equal to the total force in one direction is equal to the force in the other direction. Or it can still give us that yes, clockwise moment is equal to anti-clockwise moment. So in other words, if we make an arrow here and then another arrow here, this one, because it is turning like this, the clock, the hand of the clock in that direction, we can call it clockwise, while this one is going the other way around, anti-clockwise. So we can now denote this as anti-clockwise. So we can now say that yes, from principle of moment, from principle of moment, we say that clockwise moment is equal to anti-clockwise moment. Please, this is the formula. Anytime you are given this particular problem, always state your formula before you start. So this is your first entry. Clockwise moment is equal to anti-clockwise moment. Now the clockwise moment is this, which is F2 and X2. So clockwise moment there is F2 times X2, which is equal to the anti-clockwise moment, which is this force here, and the perpendicular distance, which is F1 and F1 times X1. So it will give us what. So this is our formula. Now we can go ahead to take one or two calculations to give meaning to this calculation. But before that, please, there are certain things that we must know. One of the things we need to know while performing this calculation is that this is a bar or a meter rule. Whenever we have a meter rule, for example, if we have a meter rule of this, the length of the meter rule is here is 0, while here is 100. Now, the weight of this meter rule is always or tend to concentrate at the midpoint. So in other words, if you are told that yes, the mass of the meter rule, if you're asked to calculate the mass of the meter rule always acts at the midpoint. That is one of the things you should note. So if it is acting at the midpoint, then you raise it there. Or they can still tell you that yes, from the question, you may be told that the mass of the rule, they will tell you where the mass of the rule acts. Maybe if it's not at 50, they can still tell you where it is active. So by the time we take calculations, we'll now know how to solve some of these problems. Okay, take the first question, and this question says, a body of mass 120 grams placed at a 10 cm mark on a uniform meter rule makes the rule settle horizontally on a fulcrum placed at a 35 cm mark. Calculate the mass of the rule. Option A, B, C, D are given there. Okay, let's take it. Now, the first thing we do is we draw the meter rule. Because they mentioned meter rule, we draw that meter rule. Okay, and of course here is 0, and the meter rule, for a meter rule, here is always 100 cm, and like we just said, the mass of the meter rule acts at the midpoint. So here is the midpoint, which is 50 cm. So this is where the mass of the meter rule will act. Now they said that a mass of 120 grams was suspended at the 10 cm mark. So here at the 10 cm mark, you drop, there's a mass here. This mass is 100 grams. The next thing, they said that the fulcrum or the support or even the knife edge is placed at 35. So we have here at 35. This is where the support is placed. Now, since this support is placed here, now once you arrange it like this, your question, the whole thing, the arrangement is made easy with this arrangement. So we now have the perpendicular distance we have here, and then we put our perpendicular distance here. Now, since from here to here is 10, from here to here is 35, from here to here is 50. Now, what will from 10 to 35 be? And of course, we now do 35 minus 10, which will give us what? 25 cm. So we can quickly put 25 here. Now, between 50 and 35, this gap here is 50 minus 35 will give us this gap. which is 15 cm. The whole thing is set. Now we can put our arrow here, put this one. This one is showing clockwise, while this one is showing anti-clockwise. Now the first step, your formula, very important. From principle of moment, we have that clockwise moment is equal to anti-clockwise moment. Having put down this, we can now go for clockwise. Now for the clockwise moment, we have mass times the distance or the force, this downward force, of course, which is the mass of the meter rule, always act as 50. So the mass of the meter rule, m times 15, will give us anti-clockwise, which is 120 times 25. Now if you press your calculator, you will now have m times 15 will give us 15m is equal to 120 times, okay, so 120 times 25 is 300. Now making m the subject of the formula, we'll divide both sides by 3,000 please, which will now give us 3,000 over 15 will give us 200 grams. Okay, by that we have 200 grams is option D. Okay, now we take okay, this question says a meter rule is found to balance at 48 cm mark. When a body of mass 60 grams is suspended at 6 cm mark, the balance point is found to be at 30 cm mark. Calculate the mass of the meter rule. Well, it's still an OBJ question, A, B, C, D. So let us look at this, how to solve this one. Okay, solution. Remember, for this one now, they said that this meter rule is found to balance at 48 cm mark. So in other words, the balance point is not, for this particular meter rule, will not be 50 grams. It will not be 50 cm, rather 48 cm mark. So in other words, the weight will now, or the mass of this meter rule will concentrate at this 48 cm mark. That is where we will calculate the mass of the meter rule. So in other words, we represent the meter rule. We have here 0, here as 100. Now the midpoint is 50. Just before the 50, we have 48. So it means that at 48 is where the mass of the meter rule will act. Okay, and they said a mass of 60 grams is suspended at 6 cm mark. So here is 6 cm mark, and then this is the 60 gram mass suspended there. Now, and they said the moment you suspend this, the knife edge will, the balance point will move. And so the balance point is now found to be at 30 cm mark. That means here is 30 cm mark is where we will now have our pivot. And they said calculate the mass of the meter rule. So in other words, the mass of the meter rule will act at the 48 cm mark. So this is M. And now, in order to having represented the mass on the left and the one on the right, so we can now put our perpendicular distances. So if we put our perpendicular distances, already this is 30, this is 6. The difference between 30 and 6 is 24. That is 30 minus 6, which is 24. Here will now give us 48 minus 30 will give us 18 there. Okay, we put our arrow clockwise and the anti-clockwise direction. Our formula will come first. We say from principle of moment, clockwise moment equals anti-clockwise moment. Now the clockwise moment will now give us m times 18. M times 18 is equal to anti-clockwise 60 times 24. 60 times 24, which will now give us 18m is equal to 60 times 24 will give us 60 times 24. It will give us 1040. Now m will give us 1140 divided by 18, which will now give us 80 grams. 80 grams is the mass of this particular meter rule. Okay, we'll take this one. This one says a uniform meter rule of mass 90 grams is pivoted at the 40 cm mark. If the meter rule is in equilibrium with an unknown mass m placed at the 10 cm mark, a 72 gram mass at the 70 cm mark, determine the value of m. So in this case, what we'll do is to represent the meter rule. Now if we represent the meter rule, we will now have that here is 0, this side is 100 cm. Now at the midpoint, that is where the mass of the meter rule will act. Now here we are given the value of the mass of the meter rule. They said the mass of the meter rule is 90 grams. So here we put the value of the meter rule, 90 grams. Now they said if the rule is in equilibrium with an unknown mass m placed at 10 cm mark. Now at 10 cm mark, another mass is suspended there. And of course, that mass is unknown. It is suspended at 10 cm mark. The next one, they said a 72 grams mass is suspended at 70 cm. Now at 70 cm now, here is 70. Another mass is suspended there. That mass is 72 grams. Now the question says, determine the mass of the meter rule. Okay. Now the pivot from the question also, they said that the pivot is at 40. So this is 40, and this is where the pivot is. So once you present this like this, once you have this arrangement, the work is easier for you. So remember, they said the mass of this meter is 90 grams, and it is pivoted at 40. So since it is pivoted at 40, this is the 40. An unknown mass is placed at 10 cm mark. Another mass placed at 70 cm mark. Now they said calculate the value of m. For us to get the value of m, we must first get perpendicular distance here, and then get the other perpendicular distances. Okay, so from here we can take from here. This one now, most people make this mistake of taking here. No, it's not just, it's not from here to here, please. It is from the point of this. Remember, this is a turning effect, but a point of pivot. So you must take this one to the point of pivot. So it cannot be here. So to the point of pivot. So this second one will now be from here, from the point of pivot to where this one is hanging. And of course, this one is hanging at 70. Pivot is at 40. So the distance from here to down here is 30. Now, from 50 to this place, 50 to 40, these two, the difference here is 10. Now, this one, from this pivot to where this one is hanging, is 40 minus 10, which will give us 30. Now, at this point now, you can put your arrows. Putting your arrows, there will be two arrows here. There will be two arrows here. This one clockwise, this one clockwise, and this one anti-clockwise. From principle of moment, we have clockwise moment is equal to anti-clockwise moment. In other words, we can now have, there are two clockwise moments here, this one and this one. You must add the two. So if we do it, we'll now have this one times this. So we have, for clockwise moment, we have 90 times 10 plus this other one here, 72 times 30. 30 from here to here. 72 times perpendicular distance, which is 72 times 72 times 30, equal to the anti-clockwise. Anti-clockwise is m times 30. M times 30. So which will now give us 90 times 10 will give us 900 plus 72 times 30. So 72 times 30 will give us 72 times 30. Will give us 2,160 equals 30 m. So you can add these two. If you add these two will give us 3,060 is equal to 30 m. Make m the subject. M will give us 3,060 all over 30. This one will cancel this. Therefore, mass of this meter rule will give us 306 divided by 3. It will give us 102 grams. So mass of this meter rule is 102 grams. Alright, this is where we break the lesson to an end. Please, if you have not subscribed to this channel, do well to subscribe to this channel. Turn on your notification button or notification bell. Hit the like button. Tell me something in the comment section. If this lesson was helpful to you, tell me something in the comment section, because that is what motivates me to continue to create more videos for you. See you in my next video, where we will be treating moment of force, where we have two knife edges. This one is just a single pivot, where we'll be dealing with two pivots. Thank you very much.